Good morning, everyone. This is Charles Ely. This is our third vetting session. Today's session will be covering material in Chapter 3 of the Modeling Guidelines and Procedures. Actually, we're going to have two sessions on Chapter 3. The one today is going to cover the Standard 140 tests and the tolerances that we put around the results of those tests. This work was done for COMNET by Mangesh Basarkar, who's now with Lawrence Berkeley Lab. When he did the work, he was with Florida Solar Energy Center. So with that, I'll turn it over to Mangesh and let him make the presentation.
Thanks, Charles. So, like Charles said, when I did this work, my name is Mangesh Basarkar. Good morning, everyone. I currently work at the Lawrence Berkeley Lab. When I did this work, I was at the Florida Solar Energy Center. So let's get started. I'm going to give you a brief overview today of the COMNET specifies a two-step certification process for vetting software tools, and this is step one of that process. So it's the two-step process is basically one is the quantitative step and the other one is the qualitative step. So today's step is with the quantitative part of it. The next session, which is going to be done by Charles, will deal with the qualitative test. So in terms of the quantitative test, the tests prescribed are based on ASHRAE standard 140, the 2007 version. The tests are for verifying the basic heat transfer building physics algorithms for energy simulation programs. And the one thing we have done is to add a set of acceptance ranges or acceptance criteria around the results that have been published by the ASHRAE Standard 140 Committee for the 2007 version of the standard. The qualitative tests, I'll just briefly mention, there are up to 29 test cases depending on what purpose you're testing the program for, which basically are for testing the assumptions and baseline generation capabilities of the tool, and Charles will cover that next time. So we'll deal with the quantitative stuff today. ASHRAE Standard 140 is, I'm sure most of you are familiar with this, but for people who are not, I'll just briefly go over what 140 is. It's the standard method of test for evaluation of building energy analysis computer programs. The standard states the purpose to be specifying test procedures for evaluating the technical capabilities and ranges of applicability of computer programs that calculate thermal performance of buildings and HVAC systems. So the standard is fairly widely used. I heard numbers at the recent ASHRAE meeting that it's the third most downloaded and requested standard in the ASHRAE set of standards. I may be wrong, but it's very high. And so it's widely used, and that is the reason we decided to pick the standard. It was already in existence. It has been verified and used by a number of developers to improve their existing tools over a long period of time. So we decided to base everything on this standard for this part of the vetting process of the software vetting tool vetting process for COMNET. So the ASHRAE Standard 140 set of tests, basically building envelope as well as HVAC set of tests. So there is the thermal envelope and fabric load base case, which is a simple single zone building. And then the next set of tests basically vary the amount of mass. There's low mass, high mass, to study thermal inertia effects and how the software tools, how the various software tools calculate those effects and deal with those effects. Then there is the free flow cases where you just let the temperature drift and those calculations are tested. The index tests basically vary the internal loads and so on and so forth. So there are tests for space cooling, space heating, which were added, I think, in the 2007 standard. And there are both analytical as well as parametric variation tests for both the state cooling and heating. So that's just a brief overview of what the ASHRAE Standard 140 suite of tests is. And in terms of the rationale for developing the acceptance criteria, basically we wanted to establish a buffer range around the reference results because, we agree, we probably all agree that the reference results do not represent the absolute truth, but rather the state-of-the-art in simulation and analysis of buildings. And a result just outside of this range should also be acceptable. So what we did was we kept everything consistent with the standard 140. And although standard 140 2007, the version does not specify whether the result that is obtained from your software compared to the reference results that the standard has, whether they should be within a certain percent, whether they should be close or far away, whatever. It doesn't specify how close or far away they should be, but it does allow you to. But there is a procedure that is laid out for explaining why your result may not come close to some of the mean values from all different results. So we have also, when we did the COMNET acceptance criteria, we were consistent with that approach. We have said that any set of reference results which do not fall within the acceptance criteria, it does not mean that there have to be changes made to the tool. You can explain why you think the result of your program falls outside of that range, and that could be acceptable. So we want to be consistent with standard 140 in that regard. Where the confidence interval ranges are very narrow, we have added additional buffer zones. So I'll go through that when I actually explain the procedure for developing the acceptance ranges. In terms of the confidence interval that was actually used, I had to use a 99% confidence interval because the sample size across the test varied very considerably, and a smaller confidence interval was unable to cover the range of results. So I used the 99% confidence interval. I think I mentioned this, where the reference results are very close together. I've added a buffer range to the values that were obtained from the procedure for calculating the acceptance ranges, and that will become a little more clearer when I go through the actual procedure. And and one thing I always kept in mind was that the acceptance ranges could be narrowed by through the calculation procedures, but I made sure that the min and max values of the reference results were always were always included within the acceptance range. So that was a brief overview of the rationale and some of the things that we kept in mind when developing these acceptance criteria. And I'm going to go over to Appendix E now, which is, so if you download the COMNET guide from the website, there is a set of appendices that you get along with it. And Appendix E basically is a short description of the procedure for developing these acceptance ranges. So establishing the acceptance ranges was kind of the rationale that I just gave you a few minutes ago. What I'm going to look at now is basically the procedure that I followed with developing these acceptance ranges. So I hope this is zoomed in enough for everyone to see. So let's take a look at an example. Let's say we have results from 8 reference cases, and the reference results are on line 1. The reference max comes out to be 5.7, the min comes out to be 4.296. The mean was calculated as 5.09, and a standard deviation of 0.471. When I calculated the confidence maximum and the confidence minimum, which were basically done using these two formulae here, the confidence maximum is the LA and the minimum is the LB. The X is the mean value. The TC was the confidence coefficient, which was determined based on sample size. And here's a table which kind of gives the confidence coefficients for various sample sizes. So in terms of our example here, we have a sample size of 8. So the confidence coefficient is 3.499. So I used so we use that confidence coefficient as CC. X is basically the standard deviation. N is the number of samples, which in this case is 8. So we plug all these numbers in basically, and we get values for a confidence interval maximum of 5.712 and a minimum value of 4.467. Now, if you look at the min and the max values for the reference results from line 2 and 3, we can see that the minimum value actually does not lie within this confidence interval. So what I did was I applied a range of plus or minus 5% to these 99% confidence intervals, which gave me new values of 5.78 for the maximum and 4.255 for the minimum. Now I'm satisfied that both the min and the max from the reference results lie within the range, and those were established to be the confidence intervals for 5.712, which does include the max value, and 4.255 is basically the acceptance range for these set of results. So when we come back to the standard 140, the results specified, the results published, the standard results, the reference results published by 140 are in the form of 4 spreadsheets. So there is the results -5-2, which I'll open up right now. And there are 3 additional spreadsheets, results -5-3A, 5-3B, and 5-4. So basically, results 5-2 is the reference results for all the envelope cases. 5-3 is the analytical cooling equipment, space cooling equipment cases. 5-3B is the comparative space cooling equipment cases, and 5-4 was the heating results. So based on the procedure that I just described, I developed these acceptance ranges for each of these tests based on the sample size and checking whether the min and the max of the results was within the range or not, and making adjustments accordingly. And to be able to use these spreadsheets now, what you need to do is what you will do for your for non-standard 140 test is to enter the data that you obtain from your tool for this case 600, which is basically the base case for the envelope load. So let's say, for example, the result obtained was 5.5. In this case, an annual heating load, I think it's in megawatt hours of 5.5, let's say, for example. And the column M will tell you, whether you pass or fail this test. Now, pass or fail doesn't, in case you don't see the pass, let's put, for example, 4.1. The fail doesn't mean really that your result is not acceptable. Like I said, to be consistent with 140, we do have the option of getting an explanation for why you think the results differ from most of the standard reference programs, and it could still be acceptable. So this procedure was repeated for all the other spreadsheets, and where you enter the data for your results. Basically, in 5.3a, it is in this sheet called YD, and so on and so forth. So basically, that is how the acceptance ranges were developed and applied for the purpose of testing the basic algorithms and calculations, building physics calculations for tools to be vetted by COMNET. So.
Well, thanks, Mangesh. I'm sure there will be some questions and some comments here. So.